The two-man submarine has a maximum operating depth of 300 feet. Its basic features are conventional with a steel pressure hull, planes, and rudder for control. Its weight of only 2,800 pounds makes it easy to trailer and quickly launch by a small boat hoist or crane. The batteries are good for a full day of diving and can be recharged with the sub in the water. This quick-acting hatch may be locked or opened from either inside or outside. It contains a CB radio antenna, transducer for communications and tracking, an O-ring seal, and port for overhead visibility. Only the bow planes need be removed for towing. A bridle eliminates fishtailing and permits good maneuverability by the tender vessel. To avoid the necessity of having a diver in the water, a short stainless steel pennant is brought up over the bow and secured to the deck when not in use. Towing at speeds of 8 or 10 knots is no problem, and hundreds of miles have been logged running at sea in all kinds of weather. These features contribute to efficient handling on the surface, a seemingly minor but essentially very important part of the operation of any small sub. During a year of trials at Catalina, over 100 dives were made and a program of periodic testing initiated. Here, two hatches of the same diameter are clamped together and lowered to a depth of 500 feet. Although the arbitrary maximum operating depth is 300, several manned dives have exceeded this depth, the deepest being to 345 feet. About once a year, the entire sub is given a drop test to 500 feet. This provides a proven factor of safety of about 1.5 to 1. To facilitate topside handling and loading, reserve buoyancy and stability are important. Submarine can support 900 pounds on the surface. The removable bow planes are folded up out of the way before coming alongside a boat or dock. High-pressure air to blow ballast is carried aboard in two standard scuba tanks good for 8 dives. Metered oxygen plus a CO2 scrubber can provide life support for up to 16 hours in an emergency. Portable lead weights correct for variations in passengers and payload. Prior to diving, the operator folds down and secures the bow planes, then closes the hatch. To submerge, the forward and aft ballast tanks are flooded by opening the valve at the top of each tank. As the air bubbles out, water enters through intakes at the bottom of the tanks until they are completely flooded and submarine slowly sinks into its natural element. In calm, clear water, the wives of the crew are taken down so they can share the experience and see how safe and comfortable the sub really is. Inside, it's a shirt-sleeve environment, warm, dry, and at normal atmospheric pressure. A diver in scuba gear can be towed along without any appreciable loss of speed or control. Obviously, some jobs could be done more effectively with sub and diver working together as a team. Safety devices were constantly added. This marker buoy can be released to the surface and reeled back down. The emergency drop weight is tested with the sub in a slightly negative buoyancy condition. When the 40-pound weight is released, submarine rises to the surface so that the hatch and radio antenna are out of the water. This would be the procedure in the unlikely event water ballast could not be blown, unlikely due to several backup systems. This is a simple device, and we call it a drag snake. It's a plastic tube filled with lead shot with trails along the bottom acting as a buffer and keeping the sub at a fairly constant altitude. When water visibility is too poor to fly, the bow planes may be left off with a drag snake in place. It can be released from inside in case of fouling. With or without the snake, submarine maintains a constant stability. About 800 pounds of batteries and lead ballast keep it level and upright regardless of how the bow planes or rudder are positioned. It's like a balloon with a weight on the bottom. The interior arrangement has been planned for maximum visibility. There are a total of 11 plexiglass ports, none less than 6 inches in diameter. The operator sits upright, surrounded by 7 viewing ports, and the observer sits or lies prone with access to another 4 ports. The hull exterior has clean, simple lines rugged enough to withstand the occasional collisions that are inevitable. These two lights, plus another one under the bow, provide illumination for maneuvering in dark water or for photography. The plug-in side lights are mounted immediately below the bow planes made of plexiglass for better operator visibility. All of the viewports are equipped so a camera may be mounted either rigidly or with a pan and tilt device for both still and movie cameras. Reliable two-way voice communication between the sub and tender vessel is essential. For topside talk, small CB units are adequate, but these frequencies do not penetrate water. While submerged, a separate ultrasonic system provides good communication from any depth and up to a range of about 1 mile. This directional transducer will track submarine while submerged with an accuracy of about 10 degrees. The ultimate tool for any submersible is a port or feed-through fixture, if desired. With a little practice, it easily picks up objects and can even tie knots, secure shackles, operate instruments, take bottom samples, or perform any simple task. It is completely manual, and a quick change feature allows several different types of claws to be installed without lifting the sub out of the water. In addition to the arm, submarine is equipped to gather data by means of tape recorder, several kinds of cameras, horizontal scanning sonar, or special instruments weighing up to 150 pounds, which is approximately the maximum payload. But data is not all we gather. This dive turned out to be a practice session in recovering contemporary amphorae, and its success resulted in raising the spirits of the entire crew. From the beginning of construction in 1961, submarine has been designed to perform useful work. HydroTech Company was formed as a commercial operating service in 1962. As of June 1967, 425 dives had been logged to accomplish a broad variety of work. These jobs include a search for a sunken plane, locating the body of a drowning victim, offshore oil pipeline inspection, an insurance investigation of a sunken yacht, several sewer outfall inspections, movie studio assignments, and a submerged power cable inspection, all performed successfully and with 100% safety record. From the undersea gardens of Catalina to the redwood forests of Northern California makes a study in contrast. Highway travel to and from jobs has totaled over 14,000 miles and ranged from San Diego to Canada. One spectacular job involved the Highlight Ross Dam in Washington. A lumber company hired us to survey Ross Lake, and a logging expert rode in the sub for a first-hand look at giant trees in perfect condition still standing in the lake bed. This was an environment far different from Catalina. The lake proved to be deep, dark, and dirty. In fact, much of the work performed by submarine has been accomplished under less than ideal conditions. Special procedures were improvised and an increasing amount of instrumentation installed, especially to cope with murky water. Another interesting contract was for the U.S. Bureau of Commercial Fisheries. Marine biologists used submarine as a platform to carry special instruments and record data to help improve fishing practices. The ocean floor surrounding Santa Rosa and San Miguel Islands is a scene of active oil exploration. Here, for the first time anywhere, a team of diving geologists utilized a submersible to obtain meaningful data. Companies interested in leasing the subsea rights in areas most likely to produce oil. Also, for the first time, we provided on-the-job training so that one of the geologists could operate submarine with another geologist as observer. A fix was taken each time the sub submerged or surfaced, and these stations carefully plotted so that significant information could be pinpointed within a relatively short distance. In addition to tape recording by the observer, all communications to the surface were logged, and the sender vessel maintained at a position within range of the sub. A very important factor in petroleum geology is the recovery of rock samples. With 2 or 3 chunks of rock in the basket and one in the claw, no chances were taken. A swimmer was assigned to retrieve them before submarine came alongside, and woe betide anyone who dropped the sample overboard. In between dives, the air in the sub is freshened with a small vacuum while the batteries are given a quick charge from the generator. This work occurred intermittently during the months of March and April and a period of many storms. In spite of this, a total number of 14 working days with 66 dives were logged. Rock outcrops were located, surveyed, and sampled on about 90% of the dives in depths ranging from 100 to 300 feet. An interesting diversion occurred when we spotted a strange object in the distance which turned out to be a dead whale about 40 feet long. The odor was intense, but by approaching upwind, we got close enough to see large sharks feeding on the carcass, and it was difficult to realize that this bloated heap of rotting flesh had once been a huge, graceful mammal. Near the end of this job, a 4,000-foot transducer cable towed behind a large vessel for seismic profiling had been lost off Santa Rosa Island. In 2 days, Submarine succeeded in locating, unsnagging, and literally bringing to the surface this expensive piece of gear, a spitting climax of achievement for a tiny sub conceived in a backyard project and undoubtedly the ugly duckling in a pioneering field.